Welcome to Chapter 5, Section 1, Use Properties of Exponents. So to begin with, we're going to look at scientific notation. Scientific notation is a method in which large or small numbers can be rewritten using properties of exponents. So like I said, it's a method of writing a large or a small number using exponents. So that means you could take this number here and rewrite it as 9.022 times 10 to the right. So it's a way of writing a very large number as a small number, or the other way around, a very small number into a nice number. So these are the properties of exponents. You're going to want to know these properties frontward and backwards, and without having to think about it. I'm not too worried about using the names as long as you know what the property does. So, to begin with, this right here, am times a to the nth. Well, let's look at an example. Let's say 2, and let's not even use a number. Let's use a variable, x squared times x to the 5th. Okay? The x squared means x times x. X to the 5th means x times x times x times x times x. And all of them are being multiplied. So altogether, you should be able to count up how many times this variable is being multiplied and get x to the 7th. Now, we don't want to write this out like this all of the time. So instead, look at the numbers 2 and 5, and how will you get to 7? You add. So this property says that when you have, when the base is the same, you add the exponents. Power property. The power property says basically has 2 powers. It's saying, we'll use another example. If we had x squared cubed, this would mean that we have x times x, and we would do that 3 times. So it's x times x, x times x, x times x. And once again, all together, what would we do with these numbers to get x to the 6th? You're going to multiply them. The next one, power product. Power of a product. That means if I had x times y, and I'm going to cube it, that means I would have xy times xy times xy. And when I look at the x's, I would see that there are 3 of them, and I would look at the y's and see that there were also 3 y's. And now all you look at is you can see that you take the exponent and you distribute it. Negative exponent property. The negative exponent property is a simple one, but it just says that if you have x to the negative 2, you're going to think of it as a fraction, and whatever has the negative exponent goes to the other side of that fraction. So this would be 1 over a to the mth power. The zero property is also a nice one. A to the power of 0 is simply 1. So I could have 102 to the power of 0. That equals 1. All right, so that's that. Then the quotient property, again, you don't need to know the names, or I don't care if you know the names. The quotient property, now we're dealing with, let's say we've got x to the 7th, and we have x to the 3rd. X to the 7th is x times x times x times x. 7 x's. X to the 3rd is x times x times x. And now, let's do, for lack of a better phrase, canceling. So I'm going to make this equal to 1, this equal to 1, this equal to 1. And all I have left is x to the 4th. Well, look at this number here, these numbers. And how would we get a 4 from those? Hopefully you can see that if you subtract, 7 minus 3 gives us our answer. So you just subtract. And the quotient property is just like the product property, where the m gets distributed, the exponent distributes all the way through. All right, so now we're going to use some of these properties. This property right here, 2 powers, so it's 2 times 3, or 6 to the 6th. Now, you could use your calculator to do 6 to the power of 6. Now, calculator, let's talk about powers in calculator. Hopefully, you know that this little symbol on your calculator is the power symbol. It means that 6 to the 6th is 6 to the power of 6. And you get 46656. All right, here is a quotient. Oops. Here is a quotient. So it's 4 to the 5th and 4 to the 3rd becomes 4 to the 5 minus 3, which becomes 4 squared, which we should have memorized as 16. Negative exponent property, pretending it's a fraction, you simply put whatever that has the negative exponent on the bottom. And then, of course, with the calculator, you would do 7 power 4, 2401. All right. So now, using scientific notation, you're going to use power properties. So population. So it says covers this many square kilometers and has this many people. So the population is 2.94 times 10 to the 5th. The land area to the 5th. So quotient, there's no exponents, so you simply do 2.94. You divide it by 1.03, and you get approximately 2.85. Now you do times 10 to the quotient of powers property. So, same base, subtract the exponents. 5 minus 5 times 10 to the 0 is 1. So you end up having 2.85. There are about 3 people per square kilometer in Iceland. Okay. Now, I'm not sure, you should have seen this in chemistry and other classes, but for scientific notation, a positive power, you move to the for a positive power, you move the decimal to the right. For a negative power, move decimal to the left. Okay. I'm going to add in here, I'm going to say positive power means bigger number. Negative power means smaller number. Standard form, if you have a big decimal, then you move to the right and you use a negative exponent. If you have a big number, move left and you use a positive exponent. All right, that's how you can convert all of your scientific notations. Okay, so let's get back to guided practices. Guided practice 1, 4 squared cubed. This is a double power, so it should be 4 squared times 3 is 4 to the 6th. Number 4, all right, so here you actually do the division, all right, and this reduces to 1/3, or basically 0.67. And then over here you are subtracting, so negative 4 minus 7 becomes times 10 to the negative 11. All right, well, this is not what standard form should look like for a scientific notation. So I need to make this 6.7 times 10 to the. All right, so we have a decimal. We move to the right 1. So we use a negative exponent. So that means negative 11 and another negative becomes negative 12. Now, I've shown you how to use your calculator to do scientific notation already. So you should be able to also check your answer using the calculator. All right, so you're going to have to do this also with many different properties all at once. Here, forget about what's inside here. Just know that you have a set of parentheses and a power on the outside. that means that power works on everything inside the parentheses. Well, so now what's inside the parenthesis? It means you have x to the 5th cubed. You have y squared cubed. So when we do the power of a power property, that's looking at x to the 5/3. Well, anyway, so x to the 5th cubed means we multiply, and you end up with x to the 15th. Y squared cubed, you multiply, you end up with y to the 6th. Now, quotient property says whenever we have similar bases, we subtract the exponents. So now we have x to the 15th minus 15, and y to the 6th minus 8. So 15 minus 15 is x to the power of 0. 6 minus 8 is y to the power of -2. Now the zero product says that x to the 0 is 1. And the negative exponent says that whenever you have a negative exponent, you move it to the other side of the fraction. So you went from this to that. All right, here's another. We have power of a power again. Take the power and distribute it into the quotient. So a to the -4 squared all over b squared squared. Now we have power of a power, and when we have that, we multiply. And whenever we have a negative exponent, we put it on the other side. Only the thing with a negative exponent. All right, let's do some checkpoints. All right, this is just like that last example. Distribute the negative. And as soon as you get good at this, you can do properties very quickly in your head. Okay. And there's always lots of different ways you could do it as well. Like from here, you could use the negative exponent properties. You could use the quotient property. You could have used the quotient property up here. There are a lot of different ways to do this. I'm going to say right now, since I don't like negatives, I'm going to take this negative exponent and put it in the denominator. And I'm going to put this negative exponent and put it in the numerator. Now I'm going to subtract exponents to get 8 to the -3. And use the negative exponent property a second time and put it in the denominator. So we end up with 1 over 8 cubed. All right, I'm going to erase this, so pause the video. I want to show you another way, one of the other ways we could have done this type of problem. All right, so the other way would be to use the quotient property first and do 8, 5 minus 2, which is 8 to the 3rd. You then can go ahead and distribute, get -3, and from there, put it in the other side of a fraction. You still end up with 1 over 8 to the 3rd, but it's a little bit faster. I'm going to jump down to number 3. We'll do the scientific notation one later. Jump down to number 3, distribute. All right, and when you distribute, I'm going to assume that we can do some of the steps in our head. So when you distribute the 7, it becomes x squared to the 7th, which is x to the 14th. And then y to the negative 6 to the 7th becomes y to the negative 42. So once we have the negative exponent, it drops on the other side, and you have x to the 14th over x to the 42nd, and not x. I'm sorry, y. All right, let's jump to this number 4. We have a bunch of numbers in here, and when you have a problem like this, I'm going to recommend that you break up the problem into different pieces. Meaning, you have a negative 2 in the numerator and a 1 in the denominator. You have I'm sorry, that's all being cubed. All right. You have a squared and an a fifth, and that's also being cubed. You have a b over a b, and that is being cubed. So, how do we go about doing this one? Well, distribute. Basically, what you're looking at is you're basically looking at negative 2 over 1 cubed. You're looking at this problem, not this whole piece. You're looking at only part of it. So that becomes negative 2 cubed over 1 cubed. That becomes negative 8 over 1. You're also looking at a squared over a to the 5th, all of that cubed. Well, that's a to the 6th over a to the 15th. And we subtract and get a to the negative 9. The third piece is b over b cubed. Well, the shortest way here would be to do b over b, which is 1. 1 cubed is 1. So I've got a bunch of work here. I've got a negative 8, I've got an a to the negative 9, and a bunch of 1s. So a negative exponent, only the thing with a negative exponent moves underneath. So my final answer for all of this, for all this mess right here, is negative 8 over a to the 9th. All right, let's do this scientific notation. 4 times 10 cubed times 7 times 10 to the negative 2. All right, well, you could try to multiply this all out and then convert it back, but it's a pain in the butt. Instead, look at the pieces that are in common. 4 times 7. 10 cubed and 10 to the negative 2. When you have similar bases, you add the exponents. You get 28 times 10 is 280. All right, let's try guided practice number 6. All right, these are the large ones. All right, so there's a lot of pieces here. And I'm going to group similar things together. I'm going to have the 7 be off by itself. I'm going to put y squared and y to the negative 4 all by itself. And I'm going to put z to the 5th separated from z to the negative 1. Because each individual piece is doable. Y squared, y to the negative 4th. Add those exponents. you get y to the negative 2. Add these exponents, you get z to the 4th. Here's a negative exponent, so it goes down low. So now all you have are things in the numerator and something in the denominator. That's guided practice number 6. Guided practice number 8 is one of the divisions. So for here, before we break it up, this time I'm going to say distribute the 3 into all of this stuff. That's one way to set this up. So you could get x to the 12th, y to the negative 6th, x to the 9th, y to the 18th. And now I'm looking at individual pieces. All right? I'm looking at x to the 12th and x to the 9th. Well, looking at these numbers here, we subtract. Looking at these numbers here, we subtract. A negative exponent goes on the other side. And you have now used all of the properties. All right, we're almost done. The radius of a beach ball is 5.6 times greater than the radius of a baseball. How many times as great as the baseball's volume is the beach ball's volume? So we're putting the beach ball's volume in here, and then the baseball's volume. So the radius of a beach ball is about 5.6 times greater. So that in here, I've got 5.6 times greater than r. And what I can conclude is if you look at 4/3 over 4/3 cancels out. Pi over pi cancels out. All you're left with is 5.6 cubed r cubed. Well, r cubed over r cubed ends up disappearing, canceling out, becoming r to the 0. And you end up 5.6 cubed is about 176 times as great as the baseball volume. All right, so you need to finish the rest of the guided practices, and here are this is what we will be doing in class next time. Good luck.